Hello and welcome to my channel. In this video we will solve problem 1 and 2 of exercise 12.1 in 12th class math. The main question is solve the following linear programming problems graphically. First, maximize z equal to 3x plus 4y subject to the constraints x plus y less than or equal to 4, x greater than or equal to 0, y greater than or equal to 0. Okay. So we have to maximize this objective function subject to these conditions. Okay. Let us start solving the problem. Solution. Now we will take the first line, which is nothing but the line corresponding to this inequality. So line 1 will be x plus y equal to 4, right? So we will take x and y, which will be equal to what? 4 minus x. So when x is equal to 0, y is 4. When x is equal to 2, y is 2. When x is equal to 4, y is 0. Okay. So this is the table that we get. For line 1. Then line 2 is the line corresponding to this inequality. So there is nothing but x equal to 0. Okay. Just we have to change the inequality to equal to. Then line 3 is corresponding to this inequality. So that is y equal to 0. Okay. Now let us plot this line on the coordinate axis. So suppose this is x axis, this is y axis. Okay. This is the origin, this is x axis and this is the y axis. Let us take the points. So that is 1 here, 2, 3, 4, then 1, 2, 3, 4. Okay. Now let us plot the lines. So when x is equal to 0, y is equal to 4 for the first line. So that is 0 comma 4, that is here. Then 2 comma 2 is the next point. So that is here. And then 4 comma 0. So that is this. So if we join these 3 points, we will get this line here. Okay. So this we will name it. This line is nothing but x plus y equal to 4. Then the x equal to 0 line we have to take. So x is equal to 0 means the y axis, right? This line is called x equal to 0 and y equal to 0 means the x axis. Okay. Now we have to find the solution region for each line here. So for that we have to substitute a point in the inequalities. So put 0 comma 0 in the first inequality. So that is x plus y less than or equal to 4, right? So that is nothing but 0 plus 0 less than or equal to 4. That is 0 is less than or equal to 4, right? So therefore the inequality is satisfied, right? This is true, right? 0 less than or equal to 4 is true. So that means the inequality is satisfied for the point 0 comma 0. So the inequality is satisfied. So therefore, now since the inequality is satisfied for this point 0 comma 0, the solution region is the half plane which has the point 0 comma 0. So that means this half plane. Okay. So the solution region is the the solution region is the half plane where 0 comma 0 lies. Okay. So that means this this half plane. Now we will take the second line, so we have to put, now since the second line is x equal to 0 and that is the y axis, and since the y axis passes through the origin, we cannot put the same point 0 comma 0 since the line is passing through the origin. So what we will do is we will take another point, so that is 1 comma 1. So put 1 comma 1 in the second inequality, x greater than or equal to 0. That is, now you can see that x is 1 here, right, 1. So 1 is greater than or equal to 0. This is true, right? So therefore the inequality is satisfied. The inequality is satisfied. So therefore the solution region is the half plane where 0 comma 0 lies. Okay, so sorry, not 0 comma 0, 1 comma 1. This is 1 comma 1 because you have substituted 1 comma 1 here, right? So where is 1 comma 1 here? So the solution region will be on the right hand side of x equal to 0. So that is this. Okay, now we have to put a point in the third equality. So put again the same point because the line y equal to 0 passes through the origin. So put 1 comma 1 in y greater than or equal to 0. That is, now you can see y is 1, so 1 is greater than or equal to 0. So therefore this is true, right? Therefore the inequality is satisfied, and therefore the solution region is the half plane where one comma 1 lies. So this is y equal to 0 and 1 comma 1 is on the above of this y equal to 0. So that means the solution region is this. Okay, now if we take the intersection of all these three regions, the intersection will be this region. Okay, here, so we label this is origin O, this is, we can call it as A, and this as B. Okay, so therefore the feasible region is what? Therefore the feasible region is OA BO. Okay, OABO. And since the region is bounded, you can see that the region OABO is bounded, so the maximum or minimum will occur at the corner points, right? So since the feasible region is bounded, therefore the maximum will occur at the corner points. Okay, at one of the corner points. So first we will take the first corner point, origin, that is 0 comma 0. So we have to find the value of z at 0 comma 0. So that means it will be this 3 times 0 plus 4 times 0, because x and y are 0. So that is 0. Then at the second corner point, so that is a, and that is nothing but 4 comma 0. So z will be equal to 3 times 4 plus 4 times 0, which is 12, right? Then at the third corner point b, and that is 0 comma 4. So z is equal to 3 times 0 plus 4 times 4, which is 16. Okay. So you can see that the maximum of the objective function is 16. So therefore maximum z is equal to 16 at which point? B, which is 0 comma 4. So this is the answer. Okay. Okay, now let us go to the second problem. Minimize z equal to minus 3x plus 4y subject to x plus y less than or equal to 8, 3x plus 2y less than or equal to 12, x greater than or equal to 0, y greater than or equal to 0. So what we have to do is find the minimum of this objective function given this condition. So solution. So line 1, let us see. Line 1 is this, right? I mean the line 1 is corresponding to this inequality. So x plus 2y equal to 8. So that means we have x here, and y is what? 8 minus x divided by 2, right? So when x is 0, y is 4. Then when x is 2, y is 3, and when x is 4, y is 2, right? So this is the table for the first line. Now line 2 let us take. So that is this 3x plus 2y equal to 12. Then x and y is equal to 12 minus 3x divided by 2. Now when x is 0, y is 6. When x is 2, y is 3. When x is 4, y is 0. So this is the table for the second line. Now let us take the line 3. So that is corresponding to this inequality. So that is x equal to 0, and line 4 is corresponding to this inequality. So that is y equal to 0. Okay. Let us plot these lines now. So we have the y axis, x axis. Okay. So this is the origin, then this is the x axis, y axis, and then we have to take the point. So suppose this is 1, 2, 3, 4, 5, 6, and then this is 1, 2, 3, 4, 5, 6. So first point is 0 comma 4, so that is nothing but here. Then 2 comma 3, so that means here. 4 comma 2 that is here. So we will join these 3 points to get a line. So this line is x plus 2y equal to 8. Now second line we will plot. So first point of second line is 0, 6, then 2, 3, so that is this point here, then 4, 0. So let us join these 3 points. Okay, so that is which line? 3x plus 2y equal to 12. 3x plus 2y equal to 12. Okay. Now third line, you know, it is the y axis, x equal to 0. Fourth line is x axis, y equal to 0. Okay. Now we have to find the feasible region, and therefore we have to find the solution region of each inequality. So first of all, put 0, 0 in the first line, that is in the first inequality, that is x plus 2y less than or equal to 8. So that is 0 plus 2 times 0 less than or equal to 8, right? So that is nothing but 0 is less than or equal to 8. So therefore the inequality is satisfied. Okay, and therefore the solution region is the half plane where 0, 0 lies. So the solution region will be here for the first line. Now let us substitute 0, 0 in the second line. Put 0, 0 in the second inequality, that is 3x plus 2y less than or equal to 12. That is 3 times 0 plus 2 times 0 less than or equal to 12. That is 0 less than or equal to 12. Therefore the inequality is satisfied. Because this is true, right? So therefore the solution region is the half plane where 0, 0 lies. So that means the solution region for the second line is this here. Okay. Now you know, for the third line x equal to 0, and if x is greater than or equal to 0, the solution region is on the right hand side of y axis. So that is here. And for y greater than or equal to 0, the solution region is above the x axis, that is this. Okay. So if you look at the intersection of all the regions, that is this region. So we can, this is O, this is A, this is B, and this is C point. Okay. Now at the corner points you have to find the value of z. So at first the origin, z is equal to what? Z is this minus 3x plus 4y. So minus 3 times 0 plus 4 times 0, that is 0, right? Then at a, which is 4 comma 0, so z is nothing but minus 3 times 4 plus 4 times 0, that is minus 12. Now we have to find the point B. So point B is this, right? It is 2 comma 3 actually. You can see the common point is 2 comma 3, but still we will find it by the simultaneous method. So first what we have is x plus 2y equal to 8, x plus 2y equal to 8, and 3x plus 2y equal to 12. If we change the sign, minus minus minus, so this gets cancelled. X minus 3x is minus 2x, equal to 8 minus 12 is minus 4, right? So that means x is equal to 2. I will substitute x equal to 2 in the first line. So 2 plus 2y equal to 8. So that means 2y is equal to 6, sorry. So y is equal to 3. So point B is what? Therefore the point B is x is 2, y is 3. So at B, which is 2 comma 3, z is equal to minus 3 times 2 plus 4 times 3, so that is minus 6 plus 12, which is 6. Now at the last point, that is C, so C is what? 0 comma 4. So z is equal to minus 3 times 0 plus 4 times 4, so that is nothing but 16. Now we have to find minimum, okay, minimize z, so we have to find the minimum. So therefore the minimum z is what? This minus 12, right? At the point A, 4 comma. This is the answer. So that's it in the video. If you have liked the video, please hit the like button. If you have not subscribed my channel, please do subscribe. I will see you in the next video.